This video is going to focus on the structure of an atom as well as changes that atoms undergo when they lose or gain electrons. So let's start with the structure of an atom. You've already heard of protons, neutrons, and electrons, so really this is review. Protons and neutrons are the particles that are located in the nucleus of an atom, while electrons spin around the outside of the nucleus in the electron cloud. You also probably know that protons are positive, neutrons are neutral, and electrons are negative. The weight of each one of these particles is now going to be important. Protons and neutrons have a mass of 1 AMU each, while electrons are about 2,000 times smaller than that. So we really ignore the mass of an electron, but your protons and neutrons, remember this, will make up the mass of the atom. The first type of notation that I want you to know about is the nuclear notation for an atom. Now when we write the nuclear notation, we're going to put the mass number on top. Remember that mass number is protons plus neutrons. The number that goes on the bottom of the nuclear notation is the atomic number. The atomic number is just the number of protons for an element. The number of protons is the number that identifies the element, so that atomic number tells you whether it's carbon or oxygen or lithium or some other element. Now for a neutral atom, the number of protons is equal to the number of electrons. This information is going to let you calculate protons, neutrons, and electrons for all the elements that are on the periodic table, as long as you're given that nuclear notation. So let's look at where all the numbers for the nuclear notation come from. The atomic number is the whole number that's in each square of the periodic table. Remember, that tells you how many protons an element has. The atomic number, because it's the number of protons, it's also equal to the number of electrons for a neutral atom. The next number that you need for nuclear notation is the mass number. The mass number is the protons plus the neutrons. Now we're not going to use a decimal in our nuclear notation. We are going to use whole numbers. So what you need to do is take that atomic weight and round it to the nearest whole number. The atomic weight is the decimal number that's in every box of the periodic table. Now here are some examples. These are the three nuclear notations for carbon. You see that each one has the symbol C for the element carbon. The bottom number for each one of these notations is 6, which is the atomic number for carbon. So what's different about them is the top number. That's the mass number. This isotope has a mass number of 12, while this carbon form has a mass of 13, and this element of carbon has a mass of 14. These are called isotopes. Carbon has 3 isotopes, carbon 12, carbon 13, and carbon 14. Here are 3 isotopes of hydrogen. The first one on the left side has a mass of 1. The one in the middle has a mass of 2. And the third isotope of hydrogen has a mass of 3. So what's different about them? Well, if you look at the key in the bottom left corner of this slide, the red circles for each model are the protons. Each one of the hydrogen isotopes has 1 red proton. That's what makes the atom hydrogen. But what's different is the number of neutrons. That's really important. Isotopes are forms of the same element that have different numbers of neutrons. Got it? Alright, so that's the nuclear notation. Let's take a look at the hyphen notation. Here are those same 3 isotopes of carbon, carbon 12, carbon 13, and carbon 14. The way that you write the hyphen notation is to put the symbol for the element first, followed by a hyphen. That's why it's called a hyphen notation. And then you put the mass number. For carbon, it's either 12, 13, or 14. Now, in a neutral atom, here's lithium for example, we expect that the number of protons equals the number of electrons. We went over that a little bit earlier in this video. So the charge overall is 0 because the positive protons balance out the negative electrons. But take a look on the right side of the slide at the lithium ion. The lithium ion has 3 positive protons still in the nucleus. That's what makes it lithium. But it only has 2 negative electrons. So think about adding numbers like positive and negative in algebra. Positive 3 and negative 2 give you a sum of positive 1. That's the charge of the lithium ion. So the way that an atom and an ion are different is that an atom is neutral, no charge, while an ion has a charge. This particular example has an ion with a positive charge. Now that's a little bit tricky because you're losing electrons, but electrons are negative, so that gives the atom a positive charge to form an ion. Here's another example. This is oxygen. Now normally, oxygen has 8 positive protons and 8 negative electrons. Their sum is 0. But if you want to form the oxygen ion, you're going to keep those 8 protons in the nucleus so that the atom stays oxygen, but then we're going to add 2 electrons. If you add 2 negative electrons to the atom, you're going to form an ion with a negative 2 charge, and that's what we see happening with oxygen. The oxygen atom is just written as a capital O with no charge. The oxygen ion is written with a capital O and a negative 2 charge. So this is an example of a negatively charged ion. When you add electrons, you make a negative ion. There are 2 types of ions. The positive ones are called cations, and the way that I remember that is that the T in the middle of the word cation is like a plus sign. Cations are formed when an element loses electrons, and the elements that typically do this are your metals. The negative ions are the anions. A little mnemonic to help you with that. The word anion is a negative ion. It's created when an element gains extra electrons. And this typically happens with your nonmetals. Now one quick note about all the elements on the periodic table. Noble gases that are in that last group on the right side of the periodic table, group 18, they do not form ions at all. So that's it. That's how you calculate protons, neutrons, and electrons for an atom. And we've compared isotopes and we've compared ions. So bring all of this with you to class. We will do lots of practice so you can get really good at doing these calculations. See you next time.